Okay, so we've still got a couple of minutes. I'm going to wait until 5:30. I hope everyone's having a great day. Hello, Ashley. Brisbane, I presume. I'm going to type in the chat for those that are reading the chat. Cool. Yeah, so I was telling my colleague today, who was actually in the meeting today, that I had to change a tire, which was not fun, but we got there in the end. So we're set to start at 5:30. If there is enough people, I may just start a tiny bit earlier. Oh yeah, from Brisbane. Yes, Marina, I remember you. I did your interview. I hope you're doing well. Nice, awesome. I am going to share my screen and just do some prep to make sure that things are working. Yep. Okay. Hope that's coming up okay. If it's not, please let me know. I just realized how close my face is to the camera. I do apologize. All right. So who are we waiting on? Not many. Yeah, most of you guys are here, I think. Yeah, most of you guys are here. Well, we've still got a couple of minutes, but you guys can take yourselves off mute. This is probably not the most formal masterclass there ever was. And I guess before we start officially, I would like to just make special mention of a couple of people. So I ran through some of these with Ben. So Ben from Python WA. He might be joining us tonight. And if he does, he'll be in the chat answering people's questions if there are any questions. And also, I am a little bit nervous despite being a teacher for many years. It doesn't actually go away. The nerves do not disappear, surprisingly. So yes. Anywho, if people are having any issues with sound, well, thanks, Ashley. If any people are having issues with just transmission, please let me know. Hope everything's going to go smoothly. Such a nice thing to say. Thank you. Okay, so might get started a smidge early. How's everyone feeling? And you can do the chat. You can use the chat. How's everyone feeling about OOP and all the things, and maybe a rating of 1 to 10? You can put that down on the chat if you like. A rating of 1 to 10. 6. Cool. 5. Still confused? Yeah. I'm not surprised. It is a hard topic. 2 out of 10. Hey, Ben's joining us. Ben from Python WA. Excited to learn more. Yes. And believe me, you will. You'll just keep hitting those sweet moments of enlightenment on the journey. And it's still happening for me. I even just the other day, realized something that I had thought this whole time. Cool. Yep. Yep. My hype score. Oh, I like that. Thanks, Sierra. Cool. Nice. So yes, this is not an easy topic. So before we start officially, it is 5:29. I would like to just quickly mention that it is very normal to feel very overwhelmed with this topic. It's all-encompassing. It's quite big, it's quite large, and I think lots of people feel the pressure when they first start learning it to sort of get everything straight away. I mean, that would be really amazing, but it just sometimes, most of the time, I should say, doesn't happen that way. So yes, I think we can start now. What did Ben say in the one with Ben, Kiva? Oh, that your understanding of group is low. Okay, so I'm going to start. Can everyone see my screen? Just give me a thumbs up. Yep, cool. Awesome. Okay, so this is a very high level overview. Now, I will do a disclaimer and say, I am not an expert in this topic. As I've mentioned, I'm still on the journey myself. However, I did feel compelled to do it because there is a thing called the curse of knowledge. I don't know if you've heard of this before, but the curse of knowledge is when you are very, very advanced in your understanding of something, and it gets harder and harder to relate back to someone who's learning it from scratch. And I feel that this topic is very prone to the curse of knowledge when it's taught. So to mix things up a little bit, I would like to kind of give my take and the little bits of information that helped me and pushed me along in my understanding. And this is what that is. So I won't go through everything in super, super detail. Maybe I'll concentrate on a couple of the things that really trip people up. And I feel that are kind of glossed over usually because it's kind of put in the, oh, we know this sort of pile when we don't. And if there are any questions, please put them in the chat, and maybe Ben or maybe another knowledgeable mentor who's with us tonight can help us out. So let's get started. Oh, look at my presentation. I'm sorry, I'm so surprised. It's just nice. I didn't expect the graphics to actually do all that. Okay, so just a little bit about me. I am an associate dev, and I've been in that position for about 1 year now. I used to be a science teacher for many years, and all these other random sciencey jobs, academic type of jobs, which are probably really boring to everyone else. But I also was maybe 1.5 years ago. So I think that gives me some sort of unique take on all of these topics. And that's my QR code if you wanted to connect. So this is what I would like you to sort of focus on for this presentation on a high-level overview of OOP, understanding why we have paradigms, defining self and why it is important, defining the principles of OOP and relating it to code, and differentiating between methods and functions, which we kind of already did a little bit in class, but I think needs to be repeated, and defining instantiation, instance, and class, and explaining what the init constructor does, as well as defining composition. So just a little bit of a background on OOP. So OOP is, it's a paradigm, it's a programming paradigm, and I'll get to that in a second, what that really means. But it was established around the 1960s, 70s. Before that, a lot of our code was very procedural, meaning the interpreter reads it from the top to the bottom. There's not much dynamics to it. And you know, when you see the pictures of someone holding up like an old-fashioned photo of someone with their code, and it's like, I don't know, books and books of code. That's probably why, because it wasn't dynamic and the rest of it. But around that time, other languages started to come around. And I think the first one that was very much object-orientated, because OOP stands for object-orientated programming. The first one was Similar, and I think Smalltalk was another one. And they kind of kicked this whole paradigm off. So some other languages that came afterwards that use this paradigm, Java, Python as well, which we're doing today, and C++. So a programming paradigm that word again, is just a way for us to think about our code, a way for us to organize our code and structure it in a way that's easy to maintain, easy to extend, easy to write. And really, when you think about it, it's a way to view real world objects as code. And that's what we do when we make applications. So that makes sense. There's other paradigms, which we won't go into today, but I've listed them there. And I think functional is popular as well. But OOP is, I guess, one that people usually learn first because it is quite popular. And so for this talk, I want to introduce it in the frame of an application. So in class in Perth, Jordan mentioned animals. I'm actually just going to put my own spin on this and reference virtual pets. So I know you're probably thinking, oh my God, someone else is using animals to explain this. Oh, can't they use something else? I think people use animals because it's so easy. Like they have so many characteristics, they can do so many things. It's just quite a relatable, it's a relatable concept to everyone. You have pets. Well, I want to make it more of a application and not so much like a real world object. So we're going to be talking about virtual pets. So pretend that you have this really cool idea to build a virtual pets application. And in class, we did a dog. So we're going to start off with the same. So we're going to build a dog, right? So how have you been building things so far? You've been using functions, right? Yes, you've been using functions in class. And by the way, that's a Tamagotchi. They need to bring them back. I never had one. I missed out. Very sad about it. So virtual pets application, you've been doing this. This is what you've been doing so far, right? So you've been learning how to create functions. You've been learning about what the different parts of the function are and what happens when you call a function. The things that you need to give in your arguments, the values as your arguments so that your function will work. And so many other little bits and pieces that you're probably like, yep, too many things. Well, if you've got your head around this, that's really great. And if you haven't, it's still okay. You just need to know that functions will come up again, and they are probably going to be called something else, but they look very similar. So this is what you've been doing so far. Yay, Tamagotchis. Yes, $29. I should definitely get one. I missed out on that era. So we're going to create a dog called Ruby. So Ruby is a staffy, and I've just written a very simple function here, and it's called Dog Factory, and you'll notice why soon. So with this code, and I'll just quickly zoom over to this. With this code, you'll notice that when you return it, it's going to give you a dictionary, right? And I actually have this in PyCharm as the actual code, but I think this is big enough. Can people see this? Is this clear enough on the screen? Please give me a thumbs up. And if it's not, please let me know. Okay, great. Thank you. Right, so this code, all well and good. You can return a dog, and you've actually given the arguments of Ruby, Staffy, and 2 to satisfy the parameters of name, breed, and age. Great. However, this is not functional code. So if you want to create another dog, you'll be doing this again and again and again, and you'll have to obviously give it different values. It's kind of just, it doesn't have any functionality. It's kind of just, I dare to say, static. And the difference between what you're going to be looking at with OOP and what you've been doing now is functionality. So your code without OOP, without what we're going to talk about, is not really functional. It's not dynamic. This isn't dynamic. So that's what the point of OOP is, basically. So isn't Ruby cute? She is very cute. So that's the point of OOP. We want more than just data. We want more than just a dictionary. So OOP in Python. So we have talked about the paradigm. We've talked about OOP being a paradigm. And really, for Python, that just means being an OOP language. It means it can support the idea of objects and models. And you've probably heard this a million times now, that everything in Python is an object. Have you actually thought about what that means, though? Because I did not think about that sentence until after I understood a couple of things. And I realized if I had really thought about it before being introduced to OOP, it would have really helped me. So if everything in Python is an object is a type. So if you have a look on the left here, I've got all of these types. These are the types of data that Python gives you, right? You've got an integer, you've got a float, a string, a list, a tuple, you've got a dictionary, booleans, and you've got the none type. Yes, it is turtles all the way down. So Ben has written a comment, and that will make sense in a second. So this is the inbuilt data types that Python gives you, and you've been working with these so far. And you've been doing some of your own stuff by making functions. However, what actually makes an object an object? So if everything is a type and everything is an object, and a type is an object is a type, what actually makes something an object? How do we check that? So we see this when we check the type of something. If we check the type of something, it'll come back with this. So these are all the data types in Python. If we check the type of something that we make, we're going to get a definition, right? So the thing that is kind of popping out at me here, and I didn't really grasp at the beginning, was this class word here. So what makes an actual object an object and what defines a type as a type is this word, this class word. So anytime that you use this word, you're actually doing something really amazing. You are actually creating your own data types in Python. I didn't understand this. And when I did understand it, it was a bit mind-blowing. And I think I got it, the first time I got it really was when I sat for the same talk by Ben Fitzharding at the Python meetup. So I had received this talk already and I got it again. So it took a couple of times to sink in. And that talk is actually linked in the resources at the end of the presentation. But this talk is all about turtles all the way down. So if you check the type of something, and then you check the type of that type, and then the type of that type, it's just, you're going to see that it's turtles all the way down. Yes, it was mind-blowing. So Kiva has just shared, I think Kiva was there that time that I listened to it for the second time. Yes. So this is what is happening. So you're actually creating your own custom types when you create a class. And this is really powerful because it gives you creative license to do anything. So you could do whatever you want. You could create virtual pets, and that's what we're doing. Now, this is the way that I probably should have started learning this, is by looking at a picture. I didn't have a picture when I started learning this, and I think this probably would have helped me. So before I saw any code, a picture would have been good. So we think of classes as blueprints, a blueprint to build a house, blueprint to, or don't know what else you would use blueprints for, plumbing, all sorts of things. But it's a blueprint and it is the instructions. It contains the basic instructions on how to create the things that you want to create for your custom type. So it creates what you want. and you need to define what that thing that you want to make from it looks like and what it can do. So the way that you'll do that is by attributes, which are just variables, and with methods, which are just functions, right? So you're going to give your code functionality with those two things. And you can reuse this class again and again. It's kind of like a template. So when you use the template, when you use a class and you create objects, because everything in Python is an object and you're creating objects when you use a class, you have custom data types, as we saw, we call what you make an instance. And that makes sense because it is a reflection of the object in or at a specific point in time, but that can change. And the process of actually doing that, of actually using your class blueprint and making those objects, is called instantiation. I didn't learn this with having those words defined. They were just used, and I feel like that probably wasn't the best because it just made it sound more complex than it was. So that's what those words really are. The process is that, and that is what you're making. So if we look at our dog, Ruby, and we wanted to actually make her using a class, this is what we're doing. So we're going to define a class and we're going to instantiate Ruby. We're going to make Ruby, in other words. And Ruby is going to be a unique instance of the dog class that we're going to make. So we can make other ones too. I think he's called Happy. I'm pretty sure he's called Happy. Yes, he is called Happy. Now, I don't know how you learn best, but I like to dissect things first before I start doing them myself. I need to understand what things do and where and what is happening, basically. So I have just dissected one of our classes. So it's a dog class. And the main thing to note here is just the color coding. There's a lot of writing, and I'm just going to quickly go through some points, and these slides will be made available to you, so don't worry. But basically, this is the breakdown of just a very simple class. Nothing special, no special methods. Now, every time you have a function defined inside of a class, you will just call it a method. That's all that is. It's just a function that is bound to a class. So all of these you've seen before, but you just call them methods now. And we're going to start from the top. So when you create a class, there is a convention for naming. So you should use camel case. You should make sure it's relevant and descriptive. And you should also use no underscores. And I was like, I'm forgetting something. Yes, it's the underscores. Do not use underscores. And you'll kind of see why later. But we will come back to this red square in a second. Let's do this one. So this is where things start to be made. So this is the constructor, I guess, portion of the class. And you'll see init. Every time you have a class, you'll see this, def, init, self, and then a second line with self.name all the time, basically. So this is it's kind of packed with so many things that need explaining, but this is where this special function or method, I should call it, init, actually creates the thing that you want. So init is a constructor, and that's what it does. So it will instantiate the object that you're going to make. And the things that you pass through, or that you give it as parameters, I should say. So self, we'll get to self in a second, but the things that you put in after self are the things that you want your objects to have as attributes when you use this as your blueprint, this dog class. So I want name, breed, age, and I'm going to add something else. I'm going to add fur color just because. And self is a thing that really trips people up. And I've got another slide on just self. But you'll always have self, and self is where that functionality comes in. So self is a way to refer to the actual thing that you're creating. Self is giving the thing that you're creating self-awareness about its capabilities and what it is. And I think someone very recently talked about it being kind of like, oh, you know, self, right? You have a name. What is your name, basically? You have an age. What is your age? And you state your age. So self is kind of assigning all of these things that you pass through as your arguments every time you create a class, and we'll instantiate one, I should say, and we'll get to this yellow box in a second. But every time you make one, all the things that you give it to make an object, this self will be assigning those things to name, to breed, to age, to fur color, or whatever you put there, basically. And the init constructor uses all of these to actually make what you're wanting to make. So this is where the magic kind of happens. And anything underneath that is the method. So these are the capabilities, the functionality of it. So this is what it is. These are what it can do, basically. And I'm not going to read through too much of all of this, but I will point out a couple of things. So for, I think it was here. Oh, sorry. Do I go back? So my bad. There we go. The blue. Yes, that's where we were. So yes, this is all part of the constructor. So the constructor does all of this, and the attributes are pieces of dynamic data. I would like to just quickly mention also, there was another thing that I needed to mention. Yep, mention that. Just making sure I'm saying the things verbally, people aren't reading and they're just listening. Yes, the green. So the methods. So every method has to contain the self argument as the first parameter, similar to this, right? So it's used, so self is used to access the instance variable. So it accesses what you've actually got up here. So what the name is, what the breed is, what the age is, and it uses it to actually do what the method wants it to do. So it can use all of these things to do speak. For example, for our function, our method, I should say speak, it's going to, oh, actually, this one's not a good example. We'll do info. It's going to use name, breed, age, and fur color. It's going to get all of those and be able to use it. And I'm just going to go to the yellow. So the yellow is actually where you'll begin. So the order of things is you're going to do this. You want to create a dog. You're going to create Ruby, right? So my dog is going to be Ruby, but we don't have Ruby just yet. But you're going to say that Ruby, or my dog, is going to equal, and you're going to call the class that you've created, and then you're going to pass in, remember our brackets, you're going to actually call with the brackets, and you're going to pass in all the things that you want Ruby to be, which match all the parameters. So the pink here, all of these, name, breed, age, fur color, all of those that you want for Ruby. So you've got a name, you've got a breed, you've got an age, and you've got fur color. And this is what will happen. So the interpreter is going to go up there and read that. The init function is going to be like, huh, okay, we have this name, we've got breed, age, and fur color. And here is where the actual instance itself is being assigned all of the things that you've actually provided, all the values. So this part is the bit that's a little bit murky for people, and it is a little bit murky still, kind of a little bit for me, because the other day I only realized that the instance is actually existing already, and then you're just assigning all of these things. So just to give you an example, I'm not an expert, and I've kind of been looking at this for a year, and I still have these moments. So I think it's really important to point out. I'm going to turn the light on because I feel like I'm in a very dark room. There we go. What is the other thing that I wanted to mention to you guys on this page? Yes. Yes, I think I've said it all. Yep. All right. I have a whole thing on self though, because self is just, yeah. So I've just got a bit of code here that doesn't really have anything to do with our virtual pets. It's just very generic. And I've actually called this args on purpose, even though they're parameters up there, because I want you to make the connection of where things are coming from. So where things are coming from, so where things are being used. So self has many, well, not many, but I guess two very, very important functions. So it, in this instance, or in this situation, initializes the variables. So it initializes arg1 and arg2, and it does it here. It assigns the values that you give it. And the my method, so this is just a method over here. The self here is used to access and print the values up here. Okay, so when you assign self to your methods, you need to do that so that you can actually access everything else. It needs to be able to use what is part of or the attributes that are part of your object. And why do we need self? Well, I've just made this very bright and pink, so you can't miss it. But again, to access those variables, as I just mentioned. And also, I think that really just popped out to me there was, hold on a sec, I just got should have been, okay. Yep, there's a correction, I think somewhere for something. I think it was the code in the other page. I'll fix that before I put the presentation out.
No, that was me correcting my summary that I was doing. You could ignore my comments.
Oh,
They're all just things that I'm noting
oh, yes,
to
yes.
help. I'm just being helpful.
Perfect. Awesome. Yes, please be helpful in the chats. Please, guys, ask Ben questions. Ben knows a lot about this. So instance method parameter here as well. So we need self for this. It needs to be able to, it allows, I would say, the method to access. It needs to be able to access and manipulate the instance variables and methods within the class. And it can't do that, like I mentioned, if self isn't assigned or it isn't there. Let me just... Yes, okay. I was just checking that there was no other little bits. Okay, why do we really need this apart from, I guess, having functional code? Well, we kind of need this because we don't really want to be writing code all the time. And before I actually move on, I'm just going to go back to this page. We can create, so we've created Ruby and we can create Happy, which was him, Black Cutie. We can create those two just with one block of code, and we can keep doing that and create many, 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 many dogs, however many we want. And all we need to do is say, right, I want the next dog, can be dog 3 or my other dog. Call that function and then give it what we need or what we want that dog to have. And that's it. Just by doing that, you can just keep creating dogs, dog objects. Yay. I think we were here. Yes, we were here. So you're able to reuse your code and in a dynamic fashion. So your code will be dry. And we just had a talk on that, I think a couple of weeks ago. It will make it easier as well for you to work on projects that, might scale very quickly as well. Now, there's a lot of debate about some of these things, and I'm not going to go into those. Ben can tell you all about that. If there is any information that he knows about those debates, about the virtues of OOP and its, use as being maintainable, but let's not go there right now. Okay, so as a quick overview, the 4 main principles of OOP. We've actually kind of already looked at 2 of them. And the reason I'm showing you the words and the names for them now is because they sound scary. And then when you're told what they are, and then you're like, this is it in code, and you're like, oh, wait, hold on, I didn't get it. It kind of makes you feel that it's more complex than what it is. But I've kind of already shown you the first two just with what we've done. So it's a bit easier to wrap your head around when you just be like, oh, that was encapsulation. So encapsulation, the first one, is the concept of bundling data and methods within a single unit. We've been doing that this whole time. We have been doing that because we are making classes. Easy. So that's encapsulation. And it, in other languages, protects the data. So usually what you would have, and I think I wasn't going to show this slide, but I will show it. I'm just going to show this one. Usually what you would have in other languages is you would have things be able to be private, like attributes be private or public. But in Python, there's no such thing. There is no such thing as having public and private variables. So what I mean by that is variables that the methods inside your class can access, and also other classes. Can another class use something from this dog class, for example? So Python doesn't care about that. Python is like, everything's public. We don't have this rule, you know, we're all adults. If you want to stuff up and access something, do it and suffer the consequences. So yeah, Python is very against the grain in that way. But if you do ever find yourself wondering about this, I will just quickly mention, oh, actually, no, I took the slide out, never mind. I'll just quickly mention that in code, if you ever find yourself mentioning if something's, you know, if you really should be using something, actually, I might even just quickly show you. You'll just see it like this, for example. You'll see a double underscore or something. So you'll see one underscore if it's something that should be just used in, I think, within the actual class. And if it's double, it's like supposed to mean not. Is that correct, Ben?
I would say that is controversial and not something the students need to worry about.
Yeah, I'm just saying if you do see it. But in Python, everything is public, and your methods can use all of these things easy peasy. That's just in case you see that.
Yeah, the important part is the double underscore dunder method. That's the important, that's a built-in Python thing. So yeah.
Yes. Oh yes, that's one thing I was going to mention. The double underscore. So this is a special function. It's actually a dunder method. It's a magic method. And I think just be very careful when you use them. The reason I have made a point of just using init here and not anything else. So you've seen the string one that's in your notes. It's a double underscore string and then double underscore. The reason I haven't included that one is because you probably should learn a little bit more about them, I feel. But this one you'll see all the time. So this is a very special method. You should not change them. Don't update them. Yes, they're very special and they're very powerful. As you can see, it can create a whole class. So I'm going to go back to slides. I'll just make this bigger. There we go. And we're almost, oops, sorry. We're almost there. Yep, did that. Ah, sorry, and we're here. So we did encapsulation, abstraction. This is pretty much just hiding anything that's you don't really need. So I would dare even say that abstraction we did over here when we used we use this info method to return all these things. You know, you can return whatever you want. You can return just the name. If you don't need to actually have access to something, you can make a special method for it and present only information that you need. So for example, Ruby, if you're going to write a whole thing on like how the pet will eat, you don't want to be writing a method for the way that the dog opened its mouth, the way that the dog chews. You just want to have an eat method and that's it, and just include the information that you need. So that's a pretty simple 2 out of 4, I'd say. And the third one is inheritance, and the fourth one is polymorphism. So we haven't really talked about them, but I'll just quickly mention them because you've kind of already seen it in class. It just hasn't been defined. So inheritance is where you have classes within classes. You have a child class, and the child class inherits the attributes and the functionality of the parent class. So all of the variables and the methods. So you can create new classes from existing ones, which is quite cool. And that is something that you can use, for example, if you have a situation in your virtual pets application where you want to have cats. So if we go back to the code, if you want to have cats, well, you can't actually use the dog class. So the dog class from 4 has all of these things that dogs would do, like it's got noise up here. And I actually didn't mention this one. This is actually a variable that is bound to the class. If you see something up here above all of the methods, all of the constructor method, all of that, it's bound to the class and it's going to apply to everything as a default. So if something's going to change in one of your instances, if you don't want this to be a default, don't put that up there. Now, this is probably not great for a cat. Meow is what a cat does, doesn't woof. So we can't use this class. We need to refactor our code, and that's where the inheritance comes in. So if I go back to this page, actually, I'll show you this page. If we're going to refactor this to kind of cater to make dogs and cats and not have to repeat our code and all of that, this is what we're going to do. So we're going to actually have a generic pet parent class, and we're going to have special child classes nested inside the parent class that take care of the specifics of dogs and the specifics of cats. But anything that's kind of in common or generic to them both can go in the parent pet class. So that's really all it is. And then you're still creating unique instances of the objects when you instantiate them without any problem. And you're being dry with your code, which is what you want. So if I go back here, this is refactored. So I've actually created a parent class called pet, and I've changed the noise here, not to be woof because that doesn't apply to cats. It has to be a generic pet noise. I've still got my constructor method here. I've added weight. I've added, yep, that's all I've added. I've got eat, I've got sleep and petting and speak, because these are all things that are common to cats and dogs. And over here in our dog child class, we've got only the things that are specific to the dog class, right? So we actually created a class called dog. We've used the pet parent class. We've actually kind of used it in the same way. I don't know if you can notice this, but it's like kind of the same thing that you're doing. You're actually passing through the pet parent class. You're using that when you're instantiating, or I should say when you're creating the dog class, you're using that, and that means that you're going to have your dog objects have all of these attributes, and they're going to have all of these functionalities too. So it just is pretty simple. All you have to do is put the parent class name in the brackets, and then any attributes that are very specific to the dog just go underneath there. So when I print out or instantiate, I should say, the dog class first, I have to instantiate before I see anything. And I then call these methods, even though they're not in the dog class, because I have use the pet class, that is what I'm inheriting from, I can actually call all these methods. So I'm calling speak and eat, and I'm actually getting all of the things that I need to get. Now, another thing that I haven't mentioned is unique implementation. So actually I kind of have unique implementation, and me adding the cat class, doing the same thing using the parent class, and me actually assigning meow to noise instead of having a generic pet noise is unique implementation. So that is this. I'll just go back to, oh, no, too far. That's this, polymorphism. So it's the ability of one object to take on multiple forms achieved by creating multiple classes inherited from a single base class. Okay, so we've got multiple classes inheriting from a single base class. We've got the dog class and we've got the cat class inheriting from the pet class. So we're able to, oh, wrong way. Too far. We're able to have all of this functionality and then have very specific attributes that only belong to a dog or only belong to a cat over here. And if there was any methods that were just for the cat or for the dog, they would go here as well. And I'm just trying to think, have I missed anything from here? I've actually tried to include like my my code and what I get when I run the code. Yes, I have. For the cat. Whiskers is sleeping. Whiskers is eating. And it's meowing. And that's me calling the sleep, the speak, and the eat method on the cats that I've just instantiated. So just like before. I think that is a pretty very high level summary of those 4 things. So you kind of seen them already. You just haven't really put names on them yet. In the exercises you were doing in class, there was quite a bit of this. And I think it helps to just kind of put labels on things. So I don't know what the chat looks like, and I don't know if Ben is still with us, but I'm just going to open that up. So I've kind of got out of there. Yes. Okay. We're running good on time. Awesome. Thanks, Ben. But yeah, this is all I'm going to really go into detail about. There's so much more. And the self thing and the init is just where people really get tripped up and where I kind of got tripped up. So if this is still confusing to you, I hope that this example is very clear example, kind of clarified a couple of things for you, and that you have a better understanding of self and the init method. And I think that is the end of those things. There was a slide that I had on composition, which I won't really touch on right now. I think I'm going to maybe just show it to you just really quickly. Yep. This is the next step. And all I'm going to say about it is it's composing classes from objects that belong to other classes. So it's multiple inheritance. Now, if you haven't got your head around the other stuff, I probably just not worry about this. And we'll come back to this later. But I think for now, the important thing is to get those concepts down, like what the class is doing, what is happening, and inheritance, because you'll see that in some of the exercises that you've got. So that's all I'll say, and I'll leave it there. And it is in the slides if you would like to have a look. And I do have a resources slide that go into it in more detail. But while I'm here, I would love to invite you over to Python WA, because Python WA is going to have a talk on PyTorch and object recognition. So if you're interested in that, that is going to be on the 5th of September. But a lot of students have asked us about testing, and that's because all of your exercises for Python have had tests in them. And I think this would be a great talk for you to come to if you're interested in that. So scan the QR code, go to the website, join our Discord, and be part of the community. And this, oh yes, any questions? If Ben hasn't answered them in the chat, please ask them now. You can unmute yourself if you want, but I have listed some resources and my favorite podcasts, Python podcasts. This one, this Hot Girls Code one, is kind of like the inspiration for virtual pets. So if you listen to that, I thought that was so great the way they explained that. And I think it would be great if you listen to it too. I think some of you are memory. Real Python and Python Bytes as well, I do enjoy, but I like Real Python better. And yes, the slides that blew my mind, Ben's presentation, are here as well. They're linked. So if you want to go and have a look at those slides and maybe even listen to Ben's talk one day, make sure you come to Python WA. So yeah. Oh, there was a question. I don't get, if we can have multiple parents, maybe I misheard. Multiple parents. Yeah, you can. You can inherit from multiple classes. Yeah, you can create very complex objects in that way. And the thing is, it can get so complex that, like, yes, it can get very complex. And if the understanding of the other things isn't there, I find it just takes you a little bit longer to get a good foot on this. I think it's good to sort of understand and break down a class and make sure that you know what you're doing, and when you're doing your exercises, if you've got nested classes, that you understand what's happening in there. And then you can have a look at this, I reckon. If you're ready for it, absolutely go for it. There's some links there. Well, thanks, Ashley. Is there any other questions? Just double checking. No. Okay. So I think Kate will give you these slides in due time, and the link will be available for this. So that was my first talk, my first virtual talk, despite being a teacher of 6 years and never having taught online, even during COVID. So thanks for coming, everyone. I think we can wrap it up. Thank you. Thank you. Thank you very much. I'll see you guys in class. Maybe we can do composition later if you're ready for it. Thanks, everyone. Thanks, Ben. Bye. Have a great night.